In the vast, star-strewn expanse of our solar system, beyond the fiery embrace of the sun and past the familiar orbits of our planetary neighbors, lies a realm of giants. Among these distant companions, one in particular captures our imagination like no other. Teased Europa, the fourth largest moon of Jupiter. It's a small, unassuming world, swathed in a brilliant shell of ice that gleams in the faint sunlight. Its surface, a chaotic jigsaw of fractures and ridges, hints at a dynamic and active history. And deep beneath this icy crust, scientists believe something incredible is hidden. A vast, global ocean of liquid water, a body of water so immense it could hold more than twice the volume of all the oceans on Earth combined. What makes Europa so utterly captivating is the profound question this ocean raises. Could life exist there? Europa challenges our earthly biases, presenting a scenario where life might thrive not in sunlight, but in the crushing pressure and eternal darkness of a subsurface sea. Our fascination with Europa isn't new. It's the culmination of centuries of observation and decades of dedicated scientific inquiry. For centuries after its discovery by Galileo Galilei in 1610, Europa remained little more than a tiny, unresolved speck of light. It was only with the advent of larger, more powerful telescopes in the 20th century that we began to scratch beneath the surface, metaphorically speaking. By analyzing the sunlight reflecting off Europa, astronomers detected the unmistakable signature of water ice. This was a monumental discovery, but it was only the beginning. The first robotic explorers to arrive were the twin Voyager 1 and 2 probes in 1979. Though their encounters were brief high-speed flybys, the images they sent back were revolutionary. They revealed a world unlike any we had seen before, a smooth surface crisscrossed by strange, dark lines. But the true golden age of Europa's discovery began in 1995 with the arrival of the Galileo spacecraft. For nearly 8 years, Galileo orbited Jupiter, making repeated close passes of Europa. With its advanced instruments, it peeled back the layers of mystery one by one, providing the smoking gun for a subsurface ocean. The most visually stunning features of Europa's ice shell are the intricate networks of lines that crisscross its entire surface. These vast geological formations, known as linea, give the moon the appearance of a cracked egg. Some stretch for thousands of kilometers, looking like massive scars carved into the ice. Scientists believe these are fractures caused by the immense gravitational pull of Jupiter, which stretches and squeezes the moon. Magma-like plumes of warmer, softer ice, or perhaps even liquid water from the ocean below, may have welled up through these cracks, resurfacing and refreezing, creating the dark, reddish bands we see today. Beyond the individual cracks and ridges, there are much larger and more chaotic features, known as chaos terrain. These regions look as if sections of the icy crust have been shattered into a jumble of rafts and icebergs, then frozen back into place at odd angles. This provides compelling visual evidence for a liquid or slushy layer not far below, allowing these massive blocks of ice to drift and rotate before being locked back into the shell. But beyond the visual clues, Europa provides another, more subtle line of evidence for its hidden ocean. The Galileo spacecraft detected that Europa has its own weak magnetic field. But it's not generated from within the moon's core. Instead, it's an induced magnetic field. Created as a conducting material within Europa moves through Jupiter's immensely powerful magnetic field. In the cold outer solar system, the most plausible candidate for this conductor, by far, is a salty liquid water ocean. The presence of this induced field is considered by many scientists to be the single strongest piece of evidence we have for Europa as ocean. Perhaps the most exciting and direct clue pointing to a subsurface ocean is the potential discovery of giant plumes of water vapor erupting from Europa's surface. In 2012, and in several observations since, astronomers using the Hubble Space Telescope spotted what appeared to be faint emissions of water vapor rising high above the moon's southern hemisphere. If these plumes are real, and if they are sourced directly from the subsurface ocean, they're essentially giving us a free sample of what lies beneath the ice. A future mission could simply fly through one of these plumes to taste the ocean, searching for complex organic molecules or even the chemical fingerprints of life, all without ever needing to land and drill through kilometers of ice. This all raises a fundamental question. How can a moon so far from the sun drifting in the profound cold of the outer solar system, have an ocean of liquid water? The answer lies in a relentless gravitational dance with Jupiter. As Europa follows its slightly elliptical orbit, the immense pull of Jupiter's gravity constantly stretches and flexes the entire moon. This constant cycle of squeezing and relaxing generates tremendous friction deep within Europa's interior, creating This process, known as tidal heating, is a powerful internal engine that keeps the ocean from freezing solid. It's the key to everything that makes Europa so compelling. So, let's paint a picture. Based on all this evidence, we can imagine a global ocean of salty liquid water, possibly dozens, even 100 kilometers deep. This ocean is not isolated. It's in direct contact with a rocky seafloor. And here's where things get really exciting. On Earth, we have deep-sea hydrothermal vents, volcanic hotspots on the ocean floor that spew out heat and chemical nutrients. Entire ecosystems thrive around these vents, completely independent of sunlight. The tidal heating that warms Europa's ocean could very well power similar hydrothermal vents on its ocean floor, providing the energy source needed to sustain a biosphere. So we have the three key ingredients that scientists believe are necessary for life as we know it. Liquid water, essential chemical elements, likely leached from the rocky seafloor, and a source of energy from tidal heating and potential hydrothermal vents. Europa appears to have all three, making it one of the most compelling targets in our search for extraterrestrial life. And this new era of European exploration is already underway. Two major missions are poised to rewrite the textbooks. The European Space Agency's JUICE mission, which is already on its way, and NASA's Europa Clipper, set to launch soon. These are the most powerful interplanetary probes ever sent to the outer solar system. They are equipped with sophisticated suites of instrument-sized penetrating radar, magnetometers, spectrometers, all designed to confirm the ocean's existence, measure the thickness of the ice shell, scan for plumes, and map the surface in incredible detail. The goal is to search for biosignatures, any substance, pattern, or object whose origin specifically requires a biological agent. The Hantizon and the secrets frozen into Europa's ice may soon give us the answers we've been searching for. Europa represents more than just a target for scientific investigation. It embodies a fundamental shift in our search for life beyond Earth. For decades, we looked for planets in the habitable zone around stars, where liquid water could exist on the surface. But Europa teaches us that the ingredients for life could be hidden in dark, cold places we never thought to look. The discovery of even simple microbial life in Europa's depths would be one of the most profound scientific revelations in human history. It would tell us that life is not a miracle unique to Earth, but a common cosmic occurrence. This small, bright moon, orbiting its giant parent in the cold and dark, beckons us forward. It promises to reveal not just its own secrets, but perhaps the most important secrets about ourselves and our place in the universe. The search continues, and the truth is out there, waiting. Thanks for joining us on this journey to the outer solar system. If you're fascinated by the mysteries of space, be sure to like this video and subscribe for more deep dives into the cosmos. See you next time. See you next time.